Nuclear power plants are thermal power stations which generate electrical energy from heat. They consist of numerous buildings and facilities, the most important of which are as follows. Turbine building houses several turbines as well as the generator necessary for electrical power generation. The containment building where the nuclear reactor is housed is made of meter-thick reinforced concrete. Inside this building, nuclear reactions take place where water is heated up. The cooling tower, which can be as tall as 200 meters, is where hot water is cooled. In order to easily understand the underlying principles, the following is a description of the most important components of a nuclear power plant that uses a pressurized water reactor, PWR. In the reactor pressure vessel, the nuclear reaction and the associated release of thermal energy takes place. In a pressurized water reactor, as in this case, the reactor pressure vessel stands about 12 meters tall. The walls are about 25 centimeters thick. Inside is where the fuel assemblies can be found. In pressurized water reactors, about 150 such assemblies are installed. A single fuel assembly is composed of many fuel rods. A fuel rod is about 5 meters in length and has a diameter of about 23 centimeters. The actual nuclear fuel is found inside of each fuel rod. Small nuclear fuel pellets composed of enriched uranium or plutonium make nuclear fission chain reaction possible. In the fission chain reaction, thermal energy is released. Water is needed in order to absorb the thermal energy and keep the chain reaction going. Inside the vessel, the water is heated to over 570 degrees Fahrenheit. The water does not boil, however, since the pressurizer maintains the water pressure constant at around 160 bars. The heated water is eventually pumped to a heat exchanger, also called steam generator. These are typically in the form of a shell and tube heat exchanger. Hot water flows through the U-tubes, heating up the metal of the pipes so that any water inside the heat exchanger begins to boil. The resulting steam is eventually fed through a set of pipes to the turbine building. The steam first drives a high-pressure turbine and then is typically fed to 2 low-pressure turbines. All of the turbines are connected by a spinning shaft to the electrical generator, which in turn produces AC electricity from the shaft's rotational energy. The steam is converted again into liquid form in a condenser, and then returned back to the steam generator. The water needed for this often comes from an adjacent river, or is cooled in a cooling tower. The water circulation systems are always kept separate from one another. Water in the primary circulation system never leaves the containment building. This water is radioactive, since it has been in direct contact with the fuel rods. Water in the secondary circulation system is used to drive the turbines and is not radioactive. The cooling circulation system provides cool water and is used to condense the steam in the secondary circulation system.
So this is all about the video related to the overview of nuclear power plant. How does this nuclear power plant will work? What are the various components that we can use in case of a nuclear power plant? And you see the most important component that we can use in case of a nuclear power plant is basically the nuclear reactor, in which all the fission processes will be done. And in that fission processes, the fuel rods, and these fuel rods, we have some fuel pellets is there, in which chain reaction will take place, and this nuclear energy is released. This nuclear energy can be used to produce the steam that will be produced by the water present inside the nuclear reactor. And after that, what will be happen, that then this water will be converted into the steam, and then this steam will strike to the turbine, and after that the turbine start rotating. And when this turbine is coupled with an alternator, then alternator will start producing electricity. And after that, the this electricity will be step up by using the step up transformers, and we can receive this energy at our receiving end, or a grid station, or a substation. So this is all about the overview of the nuclear power plant. I think by watching this video, you can get an idea how this nuclear power plant exactly works. Now, coming to the advantages part of this nuclear power plant, that I have already explained to you, that these are certain advantages of the nuclear power plant, that is inexpensive, environmental friendly, require low amount of fuel, stability, high degree of safety. So these are certain advantages of the nuclear power plant. But along with these advantages, we are also having certain disadvantages of the nuclear power plant, that for making the nuclear reactor, it is very expensive to build. There will be certain chances of the accident that occur in case of a nuclear power plant. After that, when the electricity will be generated, so there is some waste product will be there. So these waste product, that is a nuclear fuel waste product, is basically a very radioactive in nature. So it creates a lot of problem for disposal of this radioactive waste. It can impact to the environment. No doubt, we are taking all the safety equipment, we are taking all the safety gadgets, so that it will not affect the environment. But anyhow, some environmental impact will be also there. Certain, you have a security threat is there, and also you have a limited fuel supply. So this is all about the today's lecture, that is how an nuclear energy can be generated, how this nuclear energy can be converted in order to produce the electricity. And in this scene, you can see how a nuclear power plant can convert the nuclear energy into your electrical energy. Now, this is all about the nuclear power plant. In our next lecture, I will discuss with you the detailed analysis of the various equipment that we are seen in this video. What is the functioning of all the equipment that we used in nuclear power plant? What is the site specification criteria for selection of a nuclear power plant? And after that, we are discussing about the efficiencies of the nuclear power plant. So up till stage, if anybody having any doubt, he or she can ask me. Up till stage, anybody having any doubt, he or she can ask me. Shall I continue next?
Yes, sir.
Okay, fine. So this is all about the nuclear power plant. Now in today's lecture, you are seeing how the nuclear energy can be converted into the electrical energy. You can see the schematic diagram of the nuclear power plant. You are discussing about the advantages and the disadvantages of the nuclear power plant, and how working of this nuclear power plant take place. Clear?